As we mentioned before, GPS GIS data provide information about a feature's location, as well as its characteristics. Typically, you would be interested in knowing what type of feature was recorded. You would also want to know when and how the data was collected, the location of the feature topic, the feature ID, and a description of the feature. Your CMT GPS data collection software will store all these bits of information about a feature into a feature record. When you transfer the collected data to your PC, the CMT PC software will be able to display the position of the feature on the map, as well as the associated descriptive information and data collection parameters. It is important to recognize, at the outset, that how you set up and perform the data collection job has a great impact on the usefulness of the collected data. In particular, you will want to make sure that you specify the proper data collection mode for each type of features. You will also want to select and set up the feature topics and descriptions in such a way as to yield the desired GIS database. We will discuss these issues next. With GPS data collection, we are concerned with three basic types of features: points, lines, and areas. A point feature is one location, for which you just need to record one position. A tree, a statue, and a house can each be recorded as a point feature. A line feature requires more than one position to represent it. You would normally record a street, or a river, as a line feature. An area feature is essentially a line feature that closes on itself to form an enclosed region. If you would like to know the size of a lake, you could record an area feature around its perimeter. Then, you will be able to see the computed area on your GPS data collector. You will also be able to see this area feature in your CMT PC software. When you collect GPS data, you could keep your GPS receiver stationary, or you could walk or drive around with it. Obviously, you would stay still while recording the position of a point feature. This is called the static mode of data collection. For the static mode, you can specify a session time. For example, with a session time of 20 seconds, you will stay still for 20 seconds, while your GPS receiver takes 20 position fixes. These 20 position fixes will be averaged to yield one XYZ position. On the other hand, when recording data for a line feature or area feature, you and your GPS receiver will be moving along the line or the perimeter of the area. Your GPS data collector will register one position at each interval that you specify. This is called the dynamic mode of data collection. Point features are always recorded in the static mode. Line and area features are generally recorded in dynamic mode. However, if a line or area feature is made up of straight line segments, you could record it by logging the connection nodes in static mode. In summary, to collect data for a feature, you will need to specify whether the feature is a point, line, or area feature. You must also specify how the position fixes are to be recorded, in static mode or in dynamic mode. For the static mode, specify the session time, which is the number of seconds the GPS receiver will stay at a point. For the dynamic mode, specify the interval between GPS fixes. When we talk about your CMT field software, I will show you how to enter these data collection parameters into the setup screens. A feature is the object that will be mapped by the GPS system. The ability to describe a feature in terms of a multi-layered database is essential for successful integration with any GIS system. For example, it is possible to map the location of each house on a city block, and simply label each coordinate position as a house. However, the addition of information such as color, size, cost, occupants, etc., will provide the ability to sort and classify the houses by these categories. The categories of descriptions for a feature are known as attributes. Attributes are like questions that you ask about the feature. For example, the attributes of the house's featured topic may be color, size, cost, and occupants. The answers to the questions posed by the attributes are called values. An appropriate value for the color attribute may be blue. This table illustrates the relationship between features, attributes, and values. When the same type of data is collected for each house that is mapped, a database is created for the house's featured topic. Similarly, for the street's featured topic, we could be recording the name, width, and condition of each street that is mapped. Tying this hierarchical structure of feature, attributes, and values to position information is the core philosophy underlying any GIS system. When the GPS and feature data records are imported into the CMTPC software, a GIS layer is created for each feature topic in the GPS job. For example, importing a GPS job that contains data for the houses and streets feature topics would create a houses topic layer and a streets topic layer in the map screen. These layers can then be incorporated with the existing GIS data. As an example of GIS topic layers, look at the map named swcvo.fmp. In the Topics panel, on the left side of the map, notice how the houses layer is placed above the streets and land plot layers. The beauty of the GIS topic layer scheme is that it lets you look at many sets of data superposed on the same map, but keeps each set of data on a separate layer. This database is much easier to manage than a jumble of all sorts of features with irrelevant descriptions. Now, let's minimize the PC screen. With this understanding of the relationship between feature topics and GIS layers, you can see why it is important that you spend some time planning how the data should be organized before going out to collect the data. Here are a few guidelines for organizing features, attributes, and values for meaningful data presentation. Keep in mind that it is the features that are tied to geographic locations and that are going to be mapped. Avoid making the mistake of creating a featured topic that is based on an attribute. Suppose you have several plots of land and want to map the area of each plot, as well as the crop that is currently planted in that plot. Because the crop changes from location to location, it would not be a good idea to make it the featured topic. I would make a featured topic that is named plot, and collect data for the attributes area and crop. My database would look like this. When I use the CMTPC program to classify the plot featured topic based on the crop attribute, each crop will be assigned a different color or area pattern, so I will be able to tell, at a glance, how my crops are distributed among the different plots of land. Now, think of a data collection project that you might take on. What featured topics would you like to collect data for? For each of the featured topics, what attributes would you like to record? What are the possible values for those attributes? Try making a chart like the one you see on this page. This will provide a clear idea of your data organization to anyone who sees your chart. Suppose you have decided on the featured topics of interest, as well as their associated attributes, and you start collecting data. For each feature, you would need to enter the feature name, the feature type, the data collection mode, the session time or time interval, the attribute name, and the value to record for that attribute. Wouldn't it be nice if you could just select from a list of feature topics, rather than entering the full feature topic name? Wouldn't it be nice if the data collector automatically knows that selected feature is a point feature, and that the desired session time is 20 seconds? Wouldn't it be nice if you could just pick an attribute name from a list of valid attribute names? And same with the values? Well, that is exactly why we want to use a feature list. The feature list provides a way for you to specify the features, attributes, and values structure, as well as the data collection parameters. You can do this on your GPS data collector. Or you can use the CMTPC program to set up the feature list, then transfer it to your data collector. The feature list file has the file name extension FBR. When a feature list is used in the field, you will simply select a feature to be mapped. Once a feature is selected, you may select an attribute for that feature. You may then select from a list an appropriate value for that attribute. What's more, the data collector will operate in the appropriate data collection mode, as dictated by the feature list. Using a feature list not only streamlines the data entry process, but also ensures consistent data entry among different users in the same organization. This example shows a feature list that specifies how data is to be collected for the houses, trees, and streets feature topics. The attribute and values are all predefined, and it is just a matter of selecting the appropriate ones to describe the feature you are mapping.
Do I have to use the same feature list for all the GPS data I will be collecting?
You can set up one or more feature lists as needed. Generally, you will want to set up one feature list for each type of project you do. If you will only be recording trees and fire hydrants in a neighborhood, then you will just need one feature list that includes the tree feature topic and the fire hydrant topic. You will use this same feature list when collecting data for each neighborhood. However, if you will also be mapping the vegetable plots and greenhouses on a farm, then you will want to set up a separate feature list for that job.